Today in this lecture we will be studying about the water analysis. We know that water available in the nature has a lot of impurities. These impurities are checked by doing the water analysis. We do the physical examination of water, chemical examination and microbiological examination. Analysis is done to determine chemical and bacteriological pollution of water, and it is also done to determine level of organic impurities present in it. Water analysis also outlines the purification process and specifies various stages in it. It ascertains whether purification of water has reached to the required standard or not. And for the water analysis, we do the sampling in accordance with IS 3025 for the physical and chemical analysis and IS 1622 for the microbiological analysis. Water sampling for the physical and chemical analysis is done in accordance with IS 3025 and water sampling for the bacteriological analysis is done in accordance with IS 1622. Modern water quality sampling guidance is given in IS 17614. This whole process we can understand with this flowchart. From any water source, we collect the water as per the sampling plan given in IS 3025, IS 1622, and then we take with the container, we bring it to the laboratory, and in the laboratory we do the physical examination, chemical examination, microbiological examination. Thereafter analyzing, we design the purification system, filtration plant, disinfection unit, etc. Once purification is done, then it is supplied to the customer or the consumer for washing, cleaning, coaching, and industrial use, etc. The physical examination, what we do, we find out color of water, whether it is admissible or not, turbidity present in the water, odor, taste, temperature of water, suspended matter, etc. We find out through physical examination. In chemical examination, we find out what is pH value of the water, what is hardness, what is chloride presence, sulfate presence, iron, nitrate, fluorides, dissolved oxygen, etc. Then we do the microbiological examination on the water. Once we ascertain all the quality of water when it is within the standard limit, then we supply it to the consumer. The drinking water specification is given in IS 10500 2012. The parameters are like that: color in Hagen unit, order, pH value, taste, turbidity, NTU maximum, and total dissolved salt. In today's lecture, we will be studying about the color. We should be 5 Hagen acceptable limit, 5 Hagen requirement, 5 Hagen care. Permissible limit in absence of alternate source is up to 15 Hagen. For finding out the determining the color, it is given IS 3025 Part 4 with the Platinum-Cobalt Visual Comparison Method. With this, we find out whether water is acceptable, whether it is in 5 Hagen to 15 Hagen, or it is more. We ascertain with this method. This method determines the color of water by visual comparison with standard platinum-cobalt solution. One color unit is defined as the color produced by a solution containing 1 milligram of platinum per liter in form of chloroplatinate ion. One H. So we will find out with the procedure. It is the true color, the water when we use for the testing, filtered water used for the testing, that is true color, and when we test in the raw form, that is known as a apparent color. It measures true color after removing turbidity suspended particle or apparent color without filtration. The method is suitable for natural water. This platinum cobalt this platinum cobalt visual comparison method is suitable for natural waters, potable waters, and domestic wastewater, but not recommended for highly colored industrial wastewater. Sample handling and preservation. Collect sample in pre-cleaned amber glass or plastic bottles. Minimum sample volume is 100 ml. We collect from the source 1 to 2 liter. Means for this test 100 ml is a minimum requirement. Analyze within 24 hours. The water what we collect from the source should be analyzed within 24 hours. If it is not, then refrigerated at 4 degrees centigrade if delayed. Because if it is more than 24 hours, there will be bacteriological development and the true color will not be able to assess. It is very essential to do the test within 24 hours, bring to room temperature. If it is stored, it has to be bring onto the room temperature, that is 27 degrees centigrade. Before testing, pH check. Measure the pH. If outside 4 to 10, we must check the sample pH. If it is outside 4 to 10, adjust pH 7 and record the adjustment. If pH value is less than 4 or greater than 10, the pH value by diluting it has to be bring or by increasing the concentration to the 7, and it should be recorded. For true color, filter the sample using 0.45 micron cellulose membrane filter or glass fiber filter. For making true color, we should filter with the 0.45 micron meter cellulose membrane filter or glass fiber filter. Rinse the filter assembly with the distilled water. Discard first 25 ml filtrate. The first 25 millimeter, when we filter, we should discard. Then we continue with the sampling, and then that water should be collected for the test. The collect next portion for the analysis. Smaller pore size may be needed, 0.2 micrometer to 0.22 micrometer for colloidal, then iron and manganese oxides again. Then this is Nessler tube. We need Nessler tube, pH meter. The apparatus required for this test. We need the Nessler tube, match Nessler tube, that should be of 50 ml, then pH meter, and then filter assembly of 0.45 micron meter. Reagents, we require potassium chloroplatinate, K2PtCl6, this is the chemical name. So potassium chloroplatinate. We also require cobaltous chloride, COCl2.6H2O, hydrochloric acid, HCl, IS265. This is hydrochloric acid, HCl concentrate. Then sodium hydroxide, NaOH, and distilled water. And if we can also, in the, it is available standard potassium cobalt solution. This platinum cobalt solution is available in the market. If we are not bringing this, we can bring this and dilute it as a standard solution. This is available in 500 CU. So directly we can purchase. Further we will see how it can be. It is utilized standard solution. Stock standard solution. Preparation of standard solution. Stock standard solution of 500 color unit. Dissolve 1.246 gram of potassium chloroplatinate, K2PtCl6, and 1 gram crystallized cobaltous chloride, COCl2.6H2O in distilled water. Add 100 ml concentrated HCl. Dilute to 1000 ml distilled water. The stock solution has 500 color units. Instead making this combination, we can directly procure this color standards available in the chemist. So these chemical shops, this we can directly have of 500 standard solution of 500 color units we can directly purchase instead of making it. If we are making, we have to take 1.246 gram of potassium platinate, potassium chloroplatinate, 1.246 gram, then 1 gram of cobalt, cobaltous chloride, and then 100 ml of is dilute in the distilled water, then add 100 ml of HCl, and then make it diluted to 1000 ml. That dilution also done with the distilled water. We can see here, we take potassium chloroplatinate, 1.246 gram, we measure it, weigh 1 gram of crystallized cobaltous chloride, COCl2.6H2O, dissolve both salts in the distilled water, add 100 ml of concentrated HCl, mix thoroughly, dilute to 1000 ml, with distilled water. So this standard solution is ready. Now we have to make working standards like one color unit, two color unit, five color unit, 10 color unit. Like this, we have to make one color unit, 10, two color unit, five color unit. Likewise, we have to make a lot of standard for comparing. So if we take this standard solution, stock standard 0.2 ml and add with 100 ml of water, then it will become of 1 CU. Likewise, 0.2 into 500 divided by 100 divided by 100, it will become 1 CU, 1 color unit. If we have to make 20 color unit, we need to take 4 ml into 500 divided by 100, so it will become 20 color unit. Likewise, we have to make number of standard solution. Take 100 ml volumetric flask, take 0.2 ml of 500 CU stock solution, transfer 0.2 ml stock solution into 100 ml volumetric flask, add distilled water partially, add distilled water up to the mark in 100 ml, stopper and mix thoroughly. Then mix thoroughly, working standard 1 CU 100 ml is ready. Pour into clean 50 ml Nessler tube for the color comparison. Then we have to take it in the Nessler tube of 50 ml for the color comparison. It is ready. Likewise, we can make for 2 color unit, 5 color unit, 10 color unit, 15 color unit, 20 up to 100 we have to make, and of that solution we have to take that 100 ml we will make for all the color units, then take for the comparison all this up to 100 color unit, and thereafter we color with we compare with the sample solution with which color it is matching, then that unit will be the sample unit, then whether it is within the 5 Hazen to 15 Hazen or it is more, it will be determined with that. So procedure for apparent color: fill moist Nessler tube to the 50 ml mark with the well mixed sample. The sample which we got, raw sample, with that we fill the Nessler tube up to 50 ml. Compare visually platinum-cobalt standard solution by looking vertically downward through the tubes against white surface, light reflected upward. If color is greater than 100 CU, dilute the sample with the distilled water and repeat. Once color is more than 100 color unit, then we dilute the sample and we record in 50 ml how much we have diluted, how much distilled water we have added. This will again come into the use in the calculation. Likewise, we do for true color, we filter it with the 0.5 micrometer, and then we take in the Nessler tube and we compare. Then we get the true color, how much is the true color. So for apparent color is same, true color only we filter it. So apparent color unfiltered visual comparison. Mix the unfiltered water thoroughly. Fill a clean moist Nessler tube with the sample up to 50 ml. This is sample, the raw sample we collected from the river, lake, stream, groundwater, and we fill this 50 ml. And now this standard sample is ready. We have prepared, place the sample tube along the platinum-cobalt standard tube. This sample is placed. Place the tube on the white surface. The surface should be white. Then we examine with which it is matching. Now we find the sample what we take. Our sample is matches with 20 color units. Then determine the apparent color that most closely matches with the sample. In this example, apparent color is 20 CU, and then record the apparent color value in the observation book. So there will be date, sample ID, apparent color, and remark. For this, apparent color has come 20 color unit. If we find that our sample is having more than 100 color units, we dilute it with the certain volume of distilled water and we record it. Then we find out how much is the color unit of that sample what we received from the field. If the sample is not diluted and moist, standard volume A, color unit will be A. Means if we have not diluted the sample from the river whatever find, and exactly we are comparing, then whatever reading has come with comparing, that will be the color unit of that sample. If it is more than 100 color unit, we add little water and we record that volume, how much water we have added as a B. If the sample is diluted, color unit 50 into 8 divided by V, A color unit value of the diluted sample, B volume of the original sample taken and diluted to 50 ml. With the example we can understand, the original sample color is too intense, color unit is greater than 100. The 10 ml sample is diluted to make 50 ml sample. Then this whatever sample from the field be diluted with 10 ml, 10 ml distilled water to make it again 50 ml. Now we again compare it how much this diluted with the additional volume of clear water. We made it 50 ml and we find out that CU of that matches with 30. Then what was the CU of the undiluted? We can find out CU is equal to 50 into the CU value of diluted sample 30, and how much dilution we did? We did with 10 ml, so 10 divided by 10, 50 into A upon B, where A is color unit of diluted sample, that is 30. B has come 10 ml we have diluted, so the value will be 50 into 30 divided by 10. It will come 150 color unit. So total, again we can summarize it. This is the sample collected. We measure the pH. If it is more than 4 up to 10, it is okay. If less than 4 and greater than 10, we have to bring it back to the 7. Then we filter it for the true color. Preparation of this platinum cobalt standard, we know that we take prepare PT cobalt stock solution 1.246 gram K2PT Cl6 plus 1 gram CoCl2 0.6 H2O in HCl, dilute to in 100 ml HCl and dilute to 1000 ml. Then it will, the color of the solution will be of the 500 color unit. Prepare from this color unit we can prepare 1, 2, 5, 10, 15, 20, 25, 30, 40, 50, 60, 100 color units. Like if we take 0.2 ml of the uh, platinum cobalt solution, what we prepared or we brought from the market standard of the 500 kilo 0.2 ml in 100 ml, 5 to ml in 100 ml, then calculation will be 0.2 into 500 ml, the concentration of that uh, platinum cobalt standard solution divided by 100. So it will give of the one color unit. Likewise, we can make for the 5, 10, 20. Likewise, we can make like 4 ml we take, it will become 20 color unit. The appearance of that that solution will be of the 4 color unit. So fill the Nessler tubes. We fill the Nessler tube with the 5 color unit, 1 color unit, 5 color unit, 10 color unit, 20 color unit, 40 color unit, and sample. First tube distilled water, others standard solution, last tube filtered sample. So the filtered sample we take, first we take the distilled water, then all this color unit, diluted color units ka, and then we have the sample standard, and then we compare it. After comparing, find the standard that matches the sample color. Then this 20 color unit has matched with our solution. If color doesn't match and it is 100 CU, if it is not matching with the 100 color unit also, then we dilute and we record how much we have done dilution, and the color unit can be measured 50 into A divided by V. A is the color unit measured after dilution and B how much volume has been added to make it 50 ml. So we find out the color unit of that 50 into, in this case, 30 divided by B was 10. So 150 color unit. Reporting nearest one CU 1 to 50, have to nearest one CU like it was 16. So we 16.5. So we have to range 1 CU 51 to 100, then 5 CU nearest, 101 to 250, 10 CU nearest, 251 to 520 CU then result is reported. So with this, how to determine the color of the water in accordance with IS 3025 be completed. It is given in the part 4. Next we will take up how to find out other values like turbidity of the water.